Hello and welcome back to our next maths lesson. And today in maths we're going to be looking at dividing numbers with remainders. So what we're doing is really concentrating down onto the rules surrounding remainders and how that can help us and make sure that we know we're along the right line. And how, if we think about this, this might affect some of our answers. So the first thing I want you to do is to try these questions here for me. Have a go now and see what you can do. Pause now. Okay, so 5 divided by 5 is 11, as you may have seen very, very quickly before. And then what we've got here is 5 divided by, or something divided by 5 equals 1,100. Now, the way in which to think about this is what's the total number there is 11, which is very similar to this. So in order to get 11, it needs to be 55. And then what we're timesing it by, we're timesing it by 100, so we need to do that as well. So our answer should be something like that. And that cancels out everything we've got going on over here. Let's have a look what the answer is. And there it is. You've still got that, in essence, 55 divided by 5, which is 11. But then we're just thinking about it in a different column, which is that bit there. And the same goes for this one here. You've still got 5 divided by 5, but we're thinking about it in terms of dividing this also by 10. So we can do that straight away. Divide by 10, that means it moves down one space. And actually what we have is 55 divided by 5, which is 11. And it's using those skills to help you when you're dividing by 50 or dividing by 10, dividing by 5, much like when you're timesing by 50 or timesing by 10, timesing by 5, you could do one step first in order to make your life easier. So Eva has 13 straws and she wants to make them into triangles. How many triangles can she make? Have a think. How would you do it? And what would that mean? Let's have a look. So what she's actually going to do is divide these 13 by 3 to make her triangle. So she can make 1 triangle, 2 triangles, 3 triangles, 4 triangles using all 12. And she's got 1 left over. She can't make another complete triangle. So that one's left over and is not needed or can't be used. So we have our 4, 1, 2, 3, 4, which is our answer, plus this 1 that we can't use, which becomes our remainder. So have a think about these ones. We've got Tommy has 14 straws. He wants to make them into triangles. How many triangles can he make? Dora has 15. How many triangles can she make? And Jack has 16. How many triangles can he make? Have a think. And I want you to think about the pattern you might see as well. Pause now. Okay, so Tommy uses 14 straws, 1, 2, 3, 4, puts them into groups of 3 and is left with 2. So we're looking at 4 remainder 2. Dora has 15 straws. So these 3 that she would have left over after making the 4 that she made before actually could be used to make that last one as well. So it's actually 5. And Tommy, the last one, he had 16. So we'd do the same thing again. 16's 1 more. So he would have 1 straw left over, which would then mean he'd have a remainder of 1 with 16. And you'll notice that we can have remainder 1 and we have remainder 2. But as soon as we would get up to remainder 3, that's actually 1 whole group. So we can't have a remainder 3. And you'll notice that we're dividing by 3. The only 2 remainders we can have is 1 and 2. And what this is that you can never have a remainder larger than what you're dividing by. Because if you do, then you can make a whole other group. So here, we can use this rule to help us here. So the first one says we've got 3,924 divided by 3 equals 1,307, remainder 3. We've got another one, 5,626 divided by 5, which gives us 1,124 remainder 6. And then we've got 3,242 divided by 4 equals 810 remainder 2. Some of these are definitely, could be correct. We'd have to work them out. Some of them are definitely wrong. We wouldn't have to go any further to know that. Have a think. Which ones would you place where and why? Okay, so the first one, this one here, the problem we've got is that we're dividing by 3 and we've got a remainder 3, which actually means there'd be one whole group, one additional group there. So this must be definitely incorrect. The second one here, we're dividing by 4 and we have remainder 2, and that's entirely possible. So this one we would have to check further to see whether or not we could do it. And this last one, we're dividing by 5 and we have remainder 6. Well, that means we could have a group of 5 and a group of 1. So the answer would actually have another group in there and would have remainder 1. So this must also be wrong. We can't have a remainder larger than what we're dividing by. So let's have a look at that in action using our bus stop method. So we've got a bus stop method down here. I'm just going to show you the counters at the same time. Remember, when you're doing it, you don't have to do the counters. You can just use the bus stop method to get your answer much, much quicker, much, much more efficient. And as long as you understand where it comes from, it should get you to the correct answer. So we put our number into our place value grid. We've got 5,000, 200s, 9 10s and 1 1, and we do our boxing. That's 1 there with 1 left over, so we can put 1 here, and that 1 left over here gets moved into the hundreds column as 10, and you can see that there. So 5 divided by 4 is 1, remainder 1, that becomes 12. Then we do 12 divided by 4, which is 3, 1 2 3, and then that would go above there. Then we do 9 divided by 4, that's 1, 2 with 1 remainder. So 2, that remainder gets brought down, exchanged into the ones column. There it is. There it is on our thing. So we've got 2, remainder 1. That makes then 11 in the ones column. Divide that 4 ways. We can get 2 whole groups with 3 left over. And that 3 left over, we've got not another column to go into. So that's going to become our remainder 3. And that's the way to go about it. So here are some questions. Have a go and try your best. Pause now and here we go. Okay, and your answers are here. You can see in this first instance here, what we're doing is circling each group, which comes up here, and what we're left with is 2, and so that goes as our remainder here. And you'll see the groups come out, and you can use the method here to help you. The same goes for this one down here. See, we're left with 3. That becomes our total remainder over here. So you can write it in either way. And I would just show, the only bit I need to show in my book or my working out is actually this bit here. Then we've got complete the divisions, use place counters to help you if you need to. If not, you can just use our 3 into 7 goes 2 with 1 left over. 3 into 15 goes 5 times, nothing carried over. 3 into 9 goes 3 times, nothing left over. 3 into 5 goes once with 2 left over. 4 goes into 8 twice. 4 goes into 5 once with 1 left over. 4 goes into 16 4 times, no left over. 4 goes into 7 once with 3 left over. 5 goes into 6 once with 1 left over. 5 goes into 15 3, nothing left over. 5 into 6 once with 1 left over. 5 into 12 goes twice with 2 leftovers. And the same over here. 3 into 3 goes once. 3 into 9 goes 3 times. 3 into 3 goes once. 3 into 5 goes once with 2 left over. Then you'd have to complete the calculations in order to judge this. So you'd have to do the calculations for those. And then you're working out what columns are empty. In this case, if I'm dividing by 4, what column would be empty? So here's our question. It's 5,627 divided by 5 equals 1,126. How do we know this is wrong without calculating it at all? Have a think. What do you think the reason might be as to why we know that this is already wrong? Well, the thing is that we know a pattern with our 5 times table, and all the patterns with our times tables will help us know whether or not our answer could be right or could be wrong. In this case, every number in the 5 times table either ends with a 5 or a 0, in which case we can never have a number that ends in a 7 giving a complete answer. There must be a remainder. And this is the case here. It would actually be remainder 2 because we could only fit 1 5 in here. Couldn't be 6. It would have to have a remainder on there. So how about this one? There are 349 people at a wedding. They are sitting at tables of groups of 8. How many tables are needed? Have a go and then we'll talk it through. Pause now. Okay, so let's have a look. So we're going to do our total number of people divided by 8. In order to work out how many tables we need, we do 8 divided by 3. Doesn't go into it, so we carry that 3 over. We do 8 into 34, and that goes 4 times with 2 left over. So 4 times with 2 left over. 8 into 29 goes 3 times with 5 left over. So there's our answer. So surely we need 43 tables. Now, this is an interesting one, because we can't have a wedding and have 5 people standing, not sitting at a table. So when you think about some of these questions, some of our worded questions to do with division, you have to think whether or not you can have remainders or you have to fill in that last one and actually make it a table, not a complete one. And in this case, we would actually have to up it to 44 tables in order for those 5 people to have a table to sit at. Yes, it won't be a full table, but at least every single person that's going to the wedding will be able to sit down. Here's some more questions. Have a go and see what you can do. Pause now. Okay, and here are our answers. First one, we've got number 4 over here. We've got different numbers along the top here. I know that if I divide these numbers by 5, the remainder will be 1. And is she correct? Yes, she's correct, because this is a 6, which is 1 more than 5, and this is a 1, which is 1 more than 0. This is a 1 more than 0. This is a 6, it's 1 more than 5, which means all of them will have 1 left over. We can't fill in all the groups. It's not a 0, it's not a 5, it's 1 more each time. So she's right. And that's how we know. There are 459 children in school. They're sitting at tables of groups of 7. He thinks we will need 65 tables. Is he right, and how do we know? Well, let's do it. 459, we're dividing by 7. So 4 divided by 7 we can't do, so it carries over. We do 45, divided by 7. So we can go through our 7 times table and see how we've got. We've got 7, 14, 21, 28, 35, 42. That's as close as we can get. And that's 6 with 3 left over. Then we go through again and we get all the way up to 35, which is 5 times. But we have some left over. We've got 4 children without a table. Now, again, we can't have people in class not sat at a table. So we do need to make sure that that table is there for those children. So that remainder would mean we'd need that additional table. So we actually need 66 tables in order for all the children to sit down. Number 7, we have some some number cards, and that needs to be put into a calculation. So how many different ways can you complete the calculation using all the digit cards so that the remainder is 1? And for an example, they've got this here. So you just need to try it out and see. What do you notice? And what you notice is the pattern between the two numbers that go here and here, and sometimes the tens and ones and here, that needs to be thought about. And Dora is thinking of a number between 500 and 600. When she divides it by one digit, it has a remainder of 4. What can Dora's answer be? And this will just be a case of trying out some in between. To add 1 by 1 to the remainder is 4. So first thing we know that if there's a remainder of 4, then we can't be dividing by 1, 2, 3, or 4. It has to be above, or if we otherwise it's won't ever have a remainder of 4. The easiest one to choose would be dividing by 5, because first off we know that all the numbers that are divisible by 5 end in a 0 or a 5. If we got a remainder of 4, it's got to either be 4 or 9. So as long as we use one of those, the number itself could be anything we like, and that would give you a remainder 4. Okay. So thank you. I know that division can be hard, remainders can be hard, but you've got to remember the patterns that we're looking for and using your times table knowledge in order to help you. The reason why the bus stop method is useful is because it is highly efficient. It allows us to deal with big numbers without being overwhelmed by those numbers. And that's the trick. Remember, you're thinking about each column as a column that you're dividing by the number. And that will help because you only have to deal with one or two digit numbers. And it just makes your life much, much easier. I know some of those questions are hard and some will be confusing, but just try your best, see how you do. And if you're confused, go back and watch some of the other videos and just run back through that method of using some of our methods, Wednesday's lesson, yesterday's lesson, in order to see how the bus stop method is used. Thank you. I'll see you in the next video. Goodbye.